equation 4, which is in your system of equations. So if you have 2 variables, you need 2 equations. 3 variables, you need 3 equations. We have an exception to this rule when we have 3 variables, 2 equations. So, and we're saying these are non-zero answers, they're all integers, non-zero, they're all positive integers. What we do is we take out your regular coefficients and your constant. We make a matrix. This is your x, your y, your z. We make a little matrix here. The other equation is sitting up there. And we do RREF, and we start from here. And this is where we say x, y, and z. Notice this x is on, this y is on. Notice z is there both times. So what we're going to do is solve those equations in terms of z. So you're going to start just by pulling this out. 1x, no y, minus 6z equals 92. You're going to pull out this equation. No x, 1y, plus 7z equals 8. We don't have a z space. Now we're going to solve for x in terms of z. So we just got to get it to say x equals. We're going to solve for y in terms of z. We need it to say y equals. Therefore, you're going to get 2 equations that just contain z. Just z in them. X equals, y equals. God bless you. The important part is right here. We're going to take this piece, and we can only use the values that are greater than 0. We can only use actually the whole numbers, but we're just going to set this greater than 0, and we're going to see where our starting point is. So solve as you would any inequality. So I get negative 15 1/3. So it's going to go from here to somewhere. I solve this, I take this piece out, greater than 0. I get z is less than 8/7. 8/7 is like 1 and a 7. So from here to here are my possible solutions. However, we can't use negative numbers, we can't use 0. So right away, we're here. We can't use any of this. We have to pull out the whole integers, the integers, the whole numbers that are positive between 0 and 8/7. In this case, there's only one integer, a 1. So you're going to pull out a 1. Now, technically, what we do is we substitute in. When z is 1, I plug it in here, I find x. When z is 1, I plug it in here, I find y. But we have a way to, because sometimes you have like 10 entries on this table. Sometimes you only have a couple, sometimes you have like 10. So an easy way to do this is put this in your y1, put this in your y2, and when you pull up your table, only copy down the ones that have positive integers in these places. A lot of times you do this, you get like 10 of these things, 20 of these things, but only like a couple of them work. So put this in your y1, just use an x, put this in your y2, use an x, and pull up your table. That's your solution. But remember, this is x, y, and z. So you just have to rewrite this x, y, and z. This guy only had one integer for us to even try. Doesn't mean if it doesn't work, if that integer doesn't work, then there's no solution. And sometimes you'll pull up your table if it has decimals, fractions, negatives, no solution if that's the case. Okay. I'll walk through another one, and then you can see kind of what it's like. The word problems work really nicely with this. Find all the different ways a collection of 100 coins consisting of pennies, dimes, and quarters. There's your x, y, and z. So it should say, let x equals the number of pennies at 1 cent. Let y equal the number of dimes at 10 cents. And z equal the number of nickels, of quarters, at 25 cents. Just put a let statement. Okay, so now you have two equations. You have 100 coins. There's your x plus y plus z equal 100. And you have what your value is worth. So the amount of pennies times its value, the amount of dimes times its value, the amount of quarters times its value will come out to be $4.99. Not unlike we did before. But before, if we did this, we had third equation. Usually the dimes were twice as much as the quarters. We had one more equation. But we only have two equations here to start with. So pull out your matrix, RREF, flip them to fractions. They have to be exact values. If you round, you will never get a true answer. So make sure these are exact values. Again, if it helps, do this. X, Y, Z. God bless you. I have 1x, no y, negative 5/3 z equals 167/3. No x, 1y, 8/3 z equals this. And it's kind of easy when you're looking at both equations. They both contain a z. So you can't really solve for z because then you'll have two different variables. So solve for x and y in terms of z. Until you get here. Then take this little piece and set this greater than 0. Take that little piece, set it greater than 0. So you're technically looking at a number line that says negative 33.4 to 16.625. Can't use negatives, can't use 0. So right away, that eliminates that. So you want the integers, the positive integers only, no zeros, from 0 to 16.625. So you're going to make a table of z's from 1, 2, 3, all the way down to 16. Those are the possible things. Rather than sit there and plug in all of them, put this in your y1, put this in your y2. Is that working for you guys? The y1, the y2 makes life so much easier. And then just copy down the ones where all of these have positive integers. If it's got a negative, can't use it. If it's got a decimal or a fraction, can't use it. So in this case, we have 5 actual solutions to this. And then just write them. It's probably right under this. X, Y, Z. Remember, this is your X. So it's going to say 59, 39, 2. 64, 31, 5. 69, 23, 8. 74, 15, 11. It's got to go by your let's statement here. These are the possible solutions. Not difficult. If you just get from somebody who wrote the steps down, was that helpful? Walking through the steps? Because, you know, sometimes you go to look at this and you say, where do I start? And this, if you miss this step, over the years, I've taught this for a zillion years now, over the years, if kids make a mistake or get stuck, it's right here. They can get all the way down to here, and then they look at these two equations and say, now what do I do? You've got to remember this. This is what's going to give you this set of z's. If you don't have that, you're going to be kind of stuck. So if you put them in your y1, y2, you won't exactly know where. Usually it starts at 1, but you won't exactly know where you end. And if there's any other constraint, like say it says, and you can't use more than, say you can't use more than 70 pennies, and this is your pennies, then you can't use these guys, if there's another constraint in there. So let this be the table that you look at for your solutions. Makes sense to you guys that weren't here? Yeah. It's repetitious. And again, the concept of doing this is to make you comfortable with this. How you can tell this is because normally you have an equation for every variable. Azidophantine is always short an equation. So you're going to get 2 variables, no, never one equation. You're going to get 3 variables, 2 equations, and triaziloxantine on that. Okay. Yep, there's my solution. We did that one in class. There's another one. Contains 24 quarters. Again, I don't know what happened to my last statements. Let x equal the number of nickels at 5 cents. Don't forget that's 5 cents, not 0.5. Y equal the number of dimes at 10 cents. And z equal the number of quarters at 25 cents. You get 2 equations, what your coins equal and what they come out to dollar-wise. If you prefer to take that second equation and multiply by 10 and get rid of your decimals, that's fine. It works the same. Again, from here, from 0 to 4, you only have, and both of these are open circles. God bless you. You only have 1, 2, 3 that you can check for. And they all happen to work. So again, put them 11, 12, 1, 14, 8, 2, and 17, 4, 3. And this kind of makes the most sense. You know, when you have 3 kinds of coins in your hand and you need them to add up to $2, this kind of makes the most sense that you're only going to get 2 equations out of this. Questions? You guys are okay with this? Okay. Five. You can tell who wrote this problem, Mr. Nate. Me Airlines. Offers tickets to Boston on their Boston to New York flights, first class, second class, and standby. So therefore, your left statement should be, let x equal first class, y equals second class, and z equals standby. There are a lot of fractions in here, but they work the same. If you want to multiply by your denominator and get rid of your fraction, once you reach this point where you're here with your inequality, that's fine. You don't have to. Just use your calculator and follow the same process. Just divide by your fraction. You get the same denominator, so it's a keep, change, flip thing. Those denominators just cancel out. And there was only one solution. You're going from 1 to 50, actually, from 33 to, this one came out positive. So you're going from 33 to 50 in your table, and there's only one solution out of that. One way to do this. When you get to your matrix, if your matrix has all those weird decimals, just hit math, fraction, enter, enter. Math, enter, enter, and you're good. Okay, and the last, I think this is the last one coming up. Is it possible to have 50 coins, pennies, dimes, and nickels? Again, I missed my left statement here. X equals pennies, Y equals dimes, N equals nickels. Is it possible? Because sometimes it doesn't work. If you have no solution, then therefore it's not possible. This one was very possible. This let statement, this inequality was a little bit different. So the max you could get, it looked like it was going down from 62 down, but the max you could get is 50 coins. And so when you put this in your table, why is the max 50? Because if you have 50 coins, is it possible to have 50 coins? So even though this came out to be 62, your z can't be more than 50. None of these can, yeah. This one we took out because of that 0. Can't have a 0. These have to be positive integers. So this was a good one to look at because this guy had a 0 in it. Even though it's a whole number, technically it's not a positive integer.
How does that work? Because it's well, it's less than 40.
Yeah, it's like a nested. Here's your 40. Here's your 62. So it's technically rides this one, but the criteria was it can't be more than 50. So Z is a coin, right? It's a quarter in this case. So you're going to start here at the 50 and go down to the 0, which is like to the 1. You have to start at the 1 to 50.
Wait, so it has to Z has to be less than 50.
Well, if you did this, if you said Z was less than 62.5, right? So you're going to go all the way up from 1 to 62. And you could possibly have solutions all in here, right? But if your coins can't total more than 50, that means these guys can't add up to more than 50. You got to add these guys up. You got to make sure they don't total more than 50.
So you have to check.
Yeah, and automatically Z can't be 62. Z can't be more than 50, right?
Yeah.
Because then you'd have 0, 0, and you can't do that either.
Couldn't you figure that out without checking it though? Because 40 is less than 40.
Well, this guy here, this guy adds up to 50. This one doesn't work because of that 0. They have to be positive integers. 0 is an integer, but not positive nor negative. These are non-zero positive integers. So you just have to like fit that criteria in. So don't even start your Z like greater than 50. And then just make sure that they add up to 50. That none of them are greater.
I made a number line, and since it's less than both of them, I just counted the part that it overlaps, so it was less than 40.
So it was less than 40? I mean, you could actually be a little bit more. Yeah, you probably that's a good spot to
I
start.
got it right.
That's fine.
Miss Barr, you have to check all of them?
No, they'll work. Just make sure you check off your number line.
I mean,
I'm sorry.
every problem we have to check.
No, once you get your answer, they're right. You did them in your calculator.
Says a restriction. It says 50 coins or there's a certain number.
Yeah, the other ones we didn't have that problem with, only because the other one said 20 coins. What did this say? 24 coins. We didn't have that problem when we hit here. This was so small. So they're going to work. The concept is when you find your solution, they do add up to 24 coins, but Z cannot be greater than that. Like if this one said Z was less than 26, we wouldn't be able to do that. We would start them at 24, less than 24. You know what I'm saying? This Z came okay. That was fine. This is what you're making your table with. So if this equation actually said Z was less than 30, we wouldn't be able to use 25, 26, 27. We're already over. In your table, you wouldn't be able to use that. You may find a solution in your table that goes greater than that, but it doesn't fit this scenario. So, you'll see it right away. These have to add up to 24 because you put that in your matrix. This is your criteria right here. You'll see it. It is not really that difficult to spot. All right. So today, as long as there's, I don't know what I'm doing. I just lost my smart board. Okay, this came back. It's a special thing you can find on your matrix. We use it for just two things. We're only going to show you an area and a Cramer's rule with determinant. But determinant is used a lot with the matrix. The thing is, it has to be a square matrix. We're only going to ask you to solve a determinant by hand if it's a 2 by 2 matrix. Everybody listening to me? Yeah. Okay. Otherwise, if it's greater than 2 by 2, you're going to put it in your calculator. But by hand, you need to know how to do a 2 by 2. So the concept is, and I really don't like using letters because that doesn't make as much sense. You know how you do your cross products? you do your cross products like this, and you say 8 is equal to 3x, well, you kind of just do the same thing here. You're going to do your cross products here. And instead of making an equal sign, we're just going to subtract them. But where this doesn't matter what order you do this in, this does. So all we're going to do is come up this way and come up this way. Just bring them both up. Don't bring them down. If you bring them up, you're fine. You're going to multiply this times this, 2 times 2, minus 1 times negative 3. And you're just going to perform this operation. Subtract a negative means I add. There's my determinant. It says this is the formula. This times this minus this times this. Just remember to cross up. Don't come down. If you come down, you did it the opposite way. So just cross up and then subtract them. Now, here's another thing. So you have this on a test, and I need to see it. I need to see your work. So you forget how to do this. So you put this into a matrix, and you check your answer. It could either be this one, or it could be the opposite way. And you're going to be able to see which one works. Agree? So if you forget and you multiply down, just put it in your matrix and check it. I'll show you in a minute how to put it in your matrix. So if you put this in, we'll do one in your matrix. Because all the other ones you have to do in your matrix.
You can only do that count.
A square, a 2 by 2 is the only one I want you to do. It's a little bit more involved when you do a 3 by 3. It has to be square. It's a little bit more involved because you have to calculate different parts. But all we care about is that you get the basic part. The rest, because you have these calculators handy, it's kind of like over the years, we stopped teaching all those other things because you're going to pick up a calculator. If you have this tool, they let you use it on the regions. They let you use it. We let you use it on the final. When you do get to calc, you'll have a section with a calculator. You'll have a section without a calculator. Like sometimes on your tests, and sometimes in here we do, but I usually just let you use your calc. But sometimes you'll have that, and on your final, or your AP test, if you take the AP for calc, sometimes you'll have a calculator part, sometimes a non-calculator part. Same as like the SATs. They give you a calculator versus a non-calculator part. So all you're going to do is put this in your matrix, and then you're going to go to matrix calc. You're going to try this, and it's the first one, determinant. So you're just going to hit determinant, and then come back and say where it was, A, B, C, whatever it was. So just try this first. Easy. Just put it in your matrix. Don't read this part. It's different. Put it in your matrix and find me the answer. Oh, I should mention one other thing. Do you notice the bars on this? The bars don't have the little hooks on them. They're straight. So when you see two straight bars, that tells you you're finding a determinant. So sometimes you'll see something like this. You'll see x equals. And you'll say, well, what do you want me to do? This tells me determinant. So all I need to do is find the determinant, and that's what my x is equal to. Okay? So what do we get for a determinant? 14. Everybody okay with that? Okay. Easy. It is. Sometimes it's a negative, but I think it's always a whole number. I think it's usually a whole number. That's a good question. But sometimes it is a negative. Sometimes it's a negative. Unless you have fractions in there, which we usually don't have fractions in our matrix. If you have fractions in your matrix, then I could see it coming out as a fraction. But if these are all whole numbers in your matrix, your determinant is a whole number. Okay, one of the uses for determinants is the area of a triangle. Now, wouldn't this be nice to have known this in geometry? When you had to find the area of your triangle. Well, yeah, because remember you had to find the altitude first, so you had to use a trig function to find it. Then you had to find the distance formula. So this would have been so much easier. And you could actually use this if you're taking SATs or anything else, if you have to find those areas of a triangle. Now here's the problem. We're going to give you a part of a triangle, and this is going to be your formula. Instead of area equals 1/2 base times height, its area equals 1/2 times the determinant. Now the reason we put a plus or minus here is because your determinant can be negative, but your areas can never be negative. So if your area comes out with a negative determinant, then you have to use the negative sign to make it positive, which your area always has to be positive. It's the same thing. If you took the absolute value of your determinant. The reason we don't do that is because it's the same lines as your determinant lines. Yeah, but that is absolutely what it is. It just happens to be the same symbol, so we just write it differently. Now, here's your one potential problem. You're going to take these guys and you're going to build a matrix. So for A, 1, 0. For B, 2, 2. For C, 4, 3. Is that a square matrix? No. It's a 3 by 2. It has to be a 2 by 2, 3 by 3, 4 by 4. So rule of thumb is you fill this column with ones. Has to be ones. Fill this with ones. I honestly can't tell you why, but that's what works. I never looked into it, but you put this in with ones. Well, you have to have a square matrix, so you have to put something else in there. So whoever came up with this found that the ones work. So now, find me the determinant of this matrix. Everybody get a determinant? -3. So now, here's my formula. So here's a problem. 1/2 times -3. Can my area ever be negative? So in this case, I need the negative sign in front of it. If my area is positive, I don't have to worry about the sign. So my area is 3/2. Simple as that. 3 vertices of a triangle, find the determinant, 1/2 the determinant. Okay, and the last thing that we're going to show you to use a determinant for, and there are many other, again, uses for a determinant. Determinants are used a lot. It's called Cramer's rule. In Cramer's rule, guys, I need your attention because I have 5 minutes to do this. We use Cramer's rule to find a solution of your systems of equations. Now, we're going to take this out and we're going to make 2 matrices. One with your coefficients and one with your constant. Now we're going to find the determinant of one of those. Which one is your square? The first one, the 2 by 2. So we're going to find the determinant of this. I'm going to give this to you because I don't want to take up too much time with this. So again, we could do -20 minus -6, which gives you -20 plus 6, which gives you -14. And sometimes we call this with a big determinant. Or just a capital D is fine. I can just write a capital D. This is your main determinant. Okay. Now, all we're going to do now is take your constant matrix and replace the coefficient matrix for each variable. So if we want to solve for x, we take this guy and we just put it in the x column. So to solve for x, we're going to replace the first row with that constant. We're going to keep the second row the same. We're going to find the determinant of the little x. We're going to throw that into your calculator, or you can cross multiply it and find it that way. And that will be 2. Oops, sorry. That will be negative 28. I'm just doing it so that we can get through this. And we're going to follow this formula. We have 2 determinants. Our main one, our x1. So we're going to take the x and we're going to divide it by the main one. This solves for x. We take the main determinant and divide it by the determinant of x, and we divide it by the main determinant. So we have negative 28 divided by negative 14. And these can come out negative because these are solutions of your systems. Okay. Then we're going to do the same for y. We're going to take your determinant of y over your main determinant. So we're going to take this y, this row, go back to your original one, and just replace this. Don't forget to go back to your original one. 4 and 3 are back, and now this guy is 10 and 11. You're going to find your determinant, which is going to be a positive 14, and we're just going to put it into this. 14 over negative 14, and this gives me negative 1. So I have a solution, and if I had a z, I would do it with the z column. If I had another variable, I would do it with that column. As many as you have. But your first one is important. This is your main one.
Why did you put it in the parentheses to
That's your solution of this whole thing. You know how you write your solution of equations, your x, y, z? There's my x was 2, my y was negative 1.
that's the determinant of the...
No, this is just the solution of this is the solution.
Okay.
Like x equals 2, y equals negative 1. Yeah, so I just kind of sprung them out.